Okay, so this is going to be quite a short lecture on the scope of a variable. I won't be telling you everything about the scope of a variable and all the rules in this lecture. I'm going to leave that for some later ones, but this is just enough information to get you started and to use them properly. What scope of a variable means is where that variable is available to us and where it's not. If it's not available to us, we can't use it, we can't put a value into it, it won't actually be there for our use. Now what I'm using is most of the program that we had in the last lecture, which we're getting the area of a rectangle here. I've given, in my main function, I have an int called num1, an int called num2, and an int called area rect. I'll get rid of that printf because that was another function that we didn't mean to have. So I calculate the area of the rectangle by calling this area rect calc function. I pass it num1 and num2. That calls this here. It makes an integer called length and an integer called width, and they get set to, so num1 gets set to length, num2 gets put into width, and then we make a new variable called area rect in here, and then I should return area rect at that point. So I'll just change that back as well to what we had originally. Okay, so that will return that value and put it into here. Now there is no confusion between this area rect and that one there as far as the C program is concerned, because this one here is associated with this function and it's only available between this point and this point here. Okay, this area rect is part of main and it is only available from that brace to that brace. It's not available outside of there. So for example, we'll just run this program to make sure that it works. And it says the area of the rectangle is 16,384, which I would assume is the wrong value, so we'll just have to check what's wrong there, and I know exactly what's wrong. I haven't put values into these, so that's what we'll just do here now. Okay, so that's there now. We'll just try it again. Still coming out incorrect. Okay, so what's wrong is that we haven't actually done the calculation here. I'd removed it, if you recall, so we'll just do that now. Area rect is assigned length by width. Okay, so we've seen some crazy value coming out there, and that's because the calculation hadn't actually been done correctly, so it was just whatever was in there. So now we see 35 is coming out there correctly, so that's working fine there. Now what I'm going to do is I'm not going to make this area rect variable here, and we're going to see what happens. So what's happening is here it's saying area rect is undeclared first use in this function. Now that's important there, it says in this function, okay, because within this function it has never heard of area rect. The fact that it was mentioned up here makes no difference to it because that's effectively private, it's not available to it, it's in this information here. Okay, so if I put back in int area rect, it works properly. And we get 35. Similarly, if I take it out of here, we get a problem. Int or area rect undeclared first use in this function. That's in main this time. It's the first time it's come across it, so it doesn't recognize what it is, so it can't work. Okay, and that's working fine there, as you can see. Now there is another place you can put variables, and that's outside of any of the functions entirely. So I'm going to put int area rect there. Okay, and in doing so I'm going to get rid of this one, and I'm going to get rid of this one. Now if it's outside of all of them entirely, it's then available to everything, or available to them all. So let's give that a go, and we see that that works perfectly. And in fact, not only does it work perfectly there, we actually don't need this return at all here. So I can get rid of that. I'll just comment it out. And change this to void. And change this to void up here to say that it's not returning anything. And you might be wondering, well, how is the answer going to get out? Well, the answer is held in a a storage area outside of everything here. So in this point, when we call the function, I don't even need to do that. We call the function, it calculates these two values and puts it into area rect, which, as we said, is held outside of everything, so it's available to both. Let's give that a go, and we see that the number comes up as area of rectangle is 35. So this is one of the ways that we have of making sure that we could return maybe more than one thing from a function, or get more than one thing out of a function. However, it's not a good idea. The reason being that this is wide open to abuse, particularly if you have a very large program amongst lots of programmers. Having variables that are sitting out there in the middle of nowhere means that when one programmer is working on it, they may use that variable and not realize what damage that's going to do to somebody else. It's a little bit like if the bank just left their money out on tables for people to pick up themselves to make it a little bit quicker within the bank, so that you didn't have to go to the cashier and get it out of your account. The chances are somebody could take your money instead of taking their own, or take more money than they were entitled to. So it's not really a good idea, but it can be done, and it's very, very efficient if it's done properly. So in many cases in embedded systems, we would use these things, putting them outside of here, in order to get something done very efficiently to save on resources elsewhere. They're known as global variables, so the variable is available to globally, it's available to the whole program. But as I said, it's fraught with problems. Now, if I do have a variable there called area rect, and I still decide I want to put one in here, so I want to say int area rect, okay. I want to make my own one inside of main, and I'm just going to set a value for that of something like 78 there. Okay. Now, what will occur here is that we'll come into main, we'll set our two numbers up, 7 and 5. We'll set a new variable called area rect, which is inside main, and we give it the value 78. We then call the area rect calculate function, send it the two numbers. This calculates the two numbers, multiplies them together, and puts it into area rect, and that's that one there that it puts it into. Okay. When we then come to print out, though, because this printf is inside main, it goes to the one closest to it, which is this one. So this one can actually override that if it's inside the brackets. So what will get printed out here, rather than the 35, it's the 78 that will actually get printed out by this. So we'll just see that here, and you can see that that says 78. So this is not necessarily very good programming practice to have global variables the same as local variables that we would have in here and so on, but just to be aware that it can be done and that you may see it in the odd program. For the time being, try to stick to keeping variable names different from each other where you can, but also making sure that all your variables are inside a function, so inside main or inside your functions, your individual functions. Try not to put them outside of any of the functions, outside of main or outside the other functions, as global variables, because you should only do that when it's right to do so, and that will be within embedded systems where we need to keep an efficiency to the program. Okay, so for the minute in ordinary C programs for the PC, you can ignore that. Now, as I said, there's more information on scope than just what I'm giving you here, but for the moment that's enough, so we'll finish at that.